Welcome to this video. In this video, I'm going to talk about the counting rules and the factorial notation. Also, I will talk briefly about the permutation. Okay. So what is the counting rule? What it says is, in a sequence of n events in which the first one has k1 possibilities, the second one has k2 possibilities, and the third one has k3 possibility, and so on. The total number of possibilities of the sequence will be k1 times, k2 times, k3 times, and then up to k sub n. Okay, so let us see some examples and then we will understand this better. A coin is tossed and a dice is rolled. Can you tell me how many possibilities for the coin? There are two possibilities, right? Either it will turn out head or turn out tail. So it will have two possibilities, and a dice is rolled. So when a dice is rolled, how many possibilities it will have? It can show up 1, 2, 3, 4, 5, 6. So there are 6 possibilities there. Now find the number of outcomes for the sequence of events. So if you roll a dice and toss a coin together, how many different possibilities there? Will be 12. That's what it says. That's what this formula says. So it says that if you do those in sequence, then the total number of possibilities will be the number of possibilities in the first times the number of possibilities in the second one, right? And then you multiply that, it will be 12. So can you think of what are the outcomes look like? It will like head and then 1, right? Head in the coin and then 2 in the dice, and then so on, and then head in the coin and then 6 on the dice. Similarly, the coin turn up. Coin can show up tail and then 1 in the dice, tail and 2, and then so on up through tail and 6. Okay, so these are the possibilities there in the sample space. Okay, the total number of possibilities in the sample space. So what it says is, you don't have to list all those outcomes. What you can do is you can find out the number of possibilities in the first event and find the number of outcomes in the possible outcomes in the second event, and you multiply them. Okay, that's how we find out. Example number 2. A particular cell phone company offers 8 models of phones, each in 3 different colors and each available with any one of 3 calling plans. How many different choices are possible? So how many models are there? So 8 different models, 3 different colors, and 3 different calling plans. So how many ways you can pick the phone? So it will be, for the model, there are 8 possible ways. For the colors, there are 3 possible ways. And then for the calling plans, there are 3 possible ways. Okay. So if you were to buy a phone with plan, then how many possible choices would you have? You can pick any one of the 8 models. You can pick any one of the 3 colors, and you can pick any one of the 3 calling plans. So you multiply them together to find out the total number of possibilities. Okay, it will be 8 times 3 is 24 times 3 is 72. That's how you find it. Okay, let's look at example number 3. How many numbers less than 1000 and greater than 99 can be found using 1, 5, and 7 without repeating any digits? So look at that. You want to make numbers between 99 and 1000 using these numbers without repeating. That's what it says. Okay, so all the numbers between 99 and 1000 will have 3 digits in them, right? So the first digit can be picked in 3 different ways. It could be 1 or 5 or 7, right? So but since you cannot repeat them, you will pick one of those here. Now how many left is 2 of those. So for the second place, you can pick 2 of those. There are 2 possible ways, right? And for the third place, you will have just one possible way. So the total is 6. So you can make only 6 numbers between 99 and 1000 by using 1, 5, and 7. Can you list what are those? One is 157, 175, 571, 517, right? And then 715 and 751. See? Without repeating any of these in a single number, these are the only possibilities. If you are allowed to repeat, if repetition is allowed, if the repetition is allowed, then you will fill these 3 digits because all the numbers between 99 and 1000 will have 3 digits. So for the first one you have 3 choices. For the second one you will have 3 choices too, right? Because your repetition is allowed, meaning you can pick 1, 1, 1 there, 111, 555, 777, and so on. Okay. So and for the third place too, there will be 3. So the total will be 27 different numbers if repetition is allowed. But since the question asks repetition is not allowed, that's the final answer. Example number 4. A particular cell phone company offers 6 models of phones, each in 5 different colors and each available with any one of 3 calling plans. This is plans, okay? This is plans. How many combinations? This is similar to example number 2, right? So there are 6 different models, there are 5 different colors, and then 3 calling plans, right? So it will be how much? 30 times 3 is 90 different possibilities. So you can pick 90 different plans there. All right. Example number 5. How many different ways can 5 different video game cartridges be arranged in a shelf? So there is a shelf with 5 places, right? And you have a 5 video game cartridges. Okay, so how many ways? The first shelf can be filled with any of those 5 different ways. For second shelf, there is just 4 different ways, because see, once you pick the first one, there are just 4 left, right? And then after you pick the second one, there are just 3 left, and then 2 left, and then 1 left. So you multiply. You use the fundamental principle of counting there to find out the total number of ways. That will be 5 times 4 is 20 times 3 is 60 times 2 is 120. That's the total number of ways. Let's look at example 6. How many even numbers are there between 3000 and 5000? So all the numbers between 3000 and 5000 will either start with 3 or 4, right? Either it will start with 3 or start with 4. And then, so there are how many choices for the first place? There are just 2 possibilities for the first place. Either you should pick 3 or 4. If you pick less than 3 or greater than 4, then it will be outside this range. It will not be between 3000 and 5000. For the first choice, there are only 2 possibilities. For the second digit, there are 10 possibilities, because you can pick 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For the third one, there are also 10 possibilities. Also, since the numbers has to be even numbers, the last digit must be even, right? So it could be either 0 or 2 or 4 or 6 or 8. So there are only 5 choices for the last one. You cannot pick 1, 3, 5, 7, 9 on the last digit, because that will make it odd. But the question is asking about the even numbers, okay? So what is the total number of possibilities here? 2 times 10 is 20 times 10 is 200 times 5 is 1000, right? These are the total number of possibilities there. But one of the thing here is, so here you can pick 3 and then 0, 0, 0. So this is allowed here, right? Because the first digit should be either 3 or 4. The second digit and third digit should be either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the third digit or the last digit can be 0 or 2 or 4, 6 or 8. So there are 5 different ways you can pick the last one. Now, so it is allowed to pick 3 here and then 0, 0, 0. So that is, it is allowed. This is including 3000. But the question says you cannot include 3000 there, right? So how many total number of ways? So cannot include 3000. 3000. So the total numbers will be 1000, but you want to exclude that one of that number, that is 3000. That is total number of numbers are 999. That is, there are only 999 even numbers between 3000 and 5000. That's what it says. And the example number 7 on the principle of counting is, how many words may or may not have meaning with 4 letters? Meaning there are 4 letters in each word can be formed that starts G and ends with O or K. So it should start with just G. There are only 1 choice that you can pick, the first one, and the last one there are just 2 choices. Okay, in the middle one you can choose any of the 26 letters there. Okay, so how many total number of ways? You need to multiply 1 times 26 times 26 times 2. So if you do that, you will get 20, that is 1352. 1352 is the total number of words you can make with starting with Z and ending with O or K. All right. Well, and then the word must have 4 letters. So the next thing we want to talk is the factorial notation. You may have seen the factorial notation before too. It's like an exclamation mark. Okay. So n factorial means n times n minus 1 times n minus 2 times 3 times 2 times 1, where n is a non-negative integer. For a non-negative integer, the factorial notation gives you the product of all the numbers below that number go through 1. Okay. So for example, 5 factorial is 120. How? Because 5 factorial means 5 times 4 times 3 times 2 times 1. That is 5 times 4 is 20 times 3 is 60 times 2 is 120 times 1 is 120. Meaning factorial of any number is you start with that number and go below 1 and then go through 1. So in each step you go down by 1 and then multiply and then go down by 1 and multiply and then so on, and you stop at 1. Okay, that's what the factorial. So 3 factorial means 6. 4 factorial means how much? 4 times 3 times 2 times 1 will be, is that 24? That is 24. Okay. So 5 factorial is 120. Similarly, you can find out any number of factorial. Now, how about the 0 factorial? So 0 factorial will be 1, but how? Look at this. You know that. Look at another thing. So what is 4 factorial? 4 factorial is 4 times 3 times 2 times 1, right? And then what is 3 times 2 times 1 is 3 factorial. You can write 4 times 3 factorial there. Similarly, how about 5 factorial? If you want to, you can write 5 factorial is 5 times 4 factorial, right? You can write this way too. So you can stop factorial at any time you want to. Okay. That's why I can write n factorial can be written as n times n minus 1 factorial. You can write that way. N times n minus 1 factorial. You can stop at n minus 1, or you can stop at n times n minus 1 times n minus 2 factorial too. You can stop in any steps. Okay. So for example, on 5 factorial, you can write 5 times 4 factorial or 5 times 4 times 3 factorial. It is okay to stop there. Okay. Now, to show that 0 factorial is 1, you can write n factorial equals to n times n minus 1 factorial. Let's take n equals to 1. What do you get? You will get 1 factorial equals to 1 times 0. 1 minus 1 is 0 factorial, right? So what is the 0 times 1 factorial? I mean, you can divide by 1 if you want to, but this is just 0 factorial. 0 factorial equals to 1 factorial is 1, right? Because 1 factorial go up to 1. That's why just 1 times 1. So this is just 1. So this proves that 0 factorial is 1. So there is no factorial for now. There is no factorial for negative numbers, fractions, and decimals. Only the positive integers have factorial, including 0. So 0 factorial is 1. 1 factorial is also 1. 2 factorial is 2. 3 factorial is 3 times 2 times 1. That is 6. 4 factorial is 24. 5 factorial is 120, and so on. Your calculator has factorial notation. Okay. You can use calculator to find out the factorial notation. Let us look at example number 9. It says find 9 factorial divided by 7 factorial without using calculator. So how do I do that? There is 9 factorial divided by 7 factorial. This is the notation for the factorial. Okay. So what we can do is, you cannot divide 9 by 7. What you do is you try to expand that factorial, 9 factorial, bigger factorial. 9 times 8 times 7 factorial. I stop there at 7 factorial because there is a 7 factorial in the denominator. Now you cancel that. What you get is 9 times 8 is 72. That's what you get. That's the answer. Okay. All right. In your calculator, you can find factorial by entering, just press math and then go to the probability on the very top. Use the right arrow to find the probability and then number 4. Okay. So math, probability, and then number 4 will give you the factorial. All right. So you can find out the factorial that way too. All right, guys. Thank you.